Why is it wrong?
Trying but not able to get it.
Hey, why is this? You're not able to go to the next slide?
Sir! Not able to go to the next slide.
Yeah.
Not able to go to the next slide.
If you will see left, bottom left, you can try it one more time. Can do it now?
Use the arrows down. In the keyboard.
No. Yes. Now it's coming. Now it's coming.
Okay.
So can you reset the time? Reset the time.
Yeah, you can.
Reset the time from.
Yeah, I reset it. It's okay.
Sir, when you say start, I'll start. Okay.
Yeah, start.
Good morning, everyone. Today, I'm going to talk about thermal energy, which is also called the heat energy from motion of particles.
We can't see your slide. We can't see your slide.
Where am I presenting? Why am I not presenting? So, wait, they can't see me.
Even we can't see you and your slide also. Yeah, now it's done.
Now can you see me?
You can put it like that also. It's okay. Yeah. Okay, start.
No,
What's
not able to go. Okay. Now I'm able to go back. Okay.
Can they see your slides?
Yes. Can everyone see mine?
Yes, Cedric.
Sir, reset the time, sir.
Yes, I reset it. It's okay. Yeah. Yeah, you can start.
Good morning, everyone. I'm Edric, and today I'm going to talk about thermal energy. It is also called the heat energy from motion of particles. Now, the definition. What is thermal energy? Thermal energy is the energy associated with the temperature of a substance and not the heat resulting from the movement of its atoms and molecules. For example, like in this picture, the atoms and molecules are moving. It is due to the thermal energy that the atoms and molecules are moving in this medium. The hotter a substance, the faster its molecules move, and is greater the thermal energy. It's a form of energy that can be transferred as heat between objects or systems. So the hotter a substance, the greater its thermal energy. The colder a substance, the less its thermal energy. Now, let us look at a few sources of thermal energy. The main source of thermal energy is the sun. Then, combustion or burning of fuels also creates a bit of thermal energy. Now, friction between the two objects can also cause thermal energy. Electricity and geothermal energy are also other sources of thermal energy. Now, let us look at the difference between heat and temperature. Heat has the total kinetic energy, while temperature has only the average kinetic energy. Heat is dependent on mass and temperature, while temperature has no dependence on mass. Heat is measured in joules, while temperature is measured in degrees Celsius, Fahrenheit, or Kelvin. Like here, in the fire is burning the tip of the rod. So the total kinetic energy is present. Then, while on the other side, the temperature becomes temperature, and it's only the average kinetic energy that's present. Now, let us look at a few methods of heat transfer. The first method is conduction. Conduction is the transfer of heat through solids without the movement of the substance itself. For example, heating a metal frying pan and when touching it. When you touch a metal frying pan, you'll feel very hot. It is due to the thermal energy generated. Only metals will conduct heat, like iron, copper, silver, gold, etc. Next. The second method is convection. Convection is a transfer of heat through liquids or gases by the movement of the fluid itself. For example, boiling of water. when the water molecules move up, and they evaporate, and the water molecules will move down, and because of the thermal energy generated. The last method is radiation. Radiation is the transfer of heat through waves without needing a medium. For example, the sun rays. When the sun rays touching the earth. Now, let us look what is specific heat capacity. Specific heat capacity is the amount of heat needed to raise the temperature of 1 kg of a substance by 1 degree Celsius. Thermal energy is related to specific heat capacity because it determines how much heat is needed to raise the temperature of a substance. The relationship between specific heat capacity and thermal energy is given by the formula Q is equal to mc delta T, where Q is the thermal energy, m is the mass of the substance, C is the specific heat capacity, and delta T is the change in temperature. A substance with high specific heat capacity requires more thermal energy to increase temperature, while one with low specific heat capacity needs less thermal energy to increase temperature. Now, let us look at a few real-life examples. They are cooking, engines, air conditioners, thermal power plants, ironing clothes, solar panels, hot air balloons, and holding hot objects. Friends, it's fun quiz time! So now I'm going to be asking individual questions. This is not a group question. I'm asking one student's name and only that student should answer. It's MCQs. I'll be asking MCQs. I'll give you options, okay? First question goes to Betya, okay? What is thermal energy? Energy from motion, heat energy from moving particles, light energy, energy from Betya. Where is Betya? Sir, where is
Yeah, you
Betya?
can ask somebody else. Otherwise, he's not there.
Okay, this question will go to Abigail then.
It's B, heat energy for moving particles.
Yay, correct, Abigail. Second question, which of these is a good conductor? This question goes to Joshua. Wood, plastic, copper, or wool?
Copper.
Yay, correct, Joshua. Third question goes to Jehovan. What is specific heat capacity measure?
Shall I answer for him?
Okay, you can answer for it. Answer for him. Answer. Answer. Okay, so it is B. Heat needed to raise 1 kg of a temperature of a substance by 1 degree Celsius. Fourth question goes to Ira. Which of these is the example of convection?
Heating a metal rod? No, touching a hot pan. I think it's that.
C. Boiling water because it's convection, it's liquid.
Oh.
Fifth question goes to Simeon. What is the SI unit of heat?
Joule.
Yay, correct, Simeon. Now, let us summarize and conclude. Thermal energy is caused due to the movement of particles of atoms and molecules. Heat transfers by three methods: conduction, convection, and radiation. Conduction is heat transfer in solids. Convection is a transfer in liquids and gases. But radiation doesn't require a medium. Thermal energy is widely used in daily life and industries. Thank you, sir, for giving me the opportunity to present this presentation to everyone. Thank you.
Very well done. Can we have a clap for Edric? It's very good, very good. I mean, it's fun time and we understood it good. So can we have a clap for Edric? Yeah. So now we have our second participants in our midst. It's her name starts from A. Name is Abigail. So can we have a clap for Abigail for her presentation? Yes. Over to Abigail.
Okay, sir, I'm in an Apple device, so I can't keep my video on while presenting.
Okay, it's okay. So you can just show your video.
Yeah. One more thing, I won't be reading everything on the screen. You can take a screenshot and read it later. I'll
Okay.
be explaining it. So can everyone see my screen?
Yes.
Okay. Digestion, transportation, respiration, and excretion. So let's learn about the first life process, digestion. Digestion is the conversion of complex food material that we eat into simpler substances so that our cell can use it for energy and its functions. It involves 5 main processes: ingestion, digestion, absorption, assimilation, and egestion. So let's just look at them a little closer. Digestion is the process of taking food in, while digestion is the process of breaking down food materials into simpler substances. It starts in our mouth and ends in our small intestine with the help of enzymes, acids, etc. And the third process is absorption. It's when our small intestine and large intestine absorb all the nutrients and give to the blood for our cells nutrition. And assimilation, that's when it's supplied to the cells. And finally, egestion, the process by which the waste material is released from the body. Let's look at life process number 2, transportation. Transportation is also known as the circulatory system. Is essential for our body as it transports the nutrition and oxygen all throughout, without which we can't live. So the main components of the circulatory system is the blood, which is the circulating fluid, the blood vessels, there are 3 types, and the heart. And since the heart is the most important one, we'll just take a closer look at it. The heart is divided into 4 chambers: the right atrium, the right ventricle, the left atrium, and the left ventricle. And the heart pumps blood to all parts of our body. You can see a picture of the circulatory system on the right side. Let's now look at the third life process, respiration. Respiration is the system which helps us to breathe and supplies oxygenated blood for the heart to pump. It has 2 processes involved: inhalation and exhalation. And the main components of the system is our nostrils, our nasal cavity, the pharynx, our windpipe or trachea, and our trachea then divides into 2 bronchi, which leads to the lungs. And the lungs have small alveoli. And so we're just gonna see how the lungs gives us oxygenated blood. When we inhale, our lungs get filled with oxygenated air, and the alveoli have thin blood capillaries. So the oxygen diffuses into the blood capillaries and the carbon dioxide diffuses into the alveoli. And then when we exhale, all the carbon dioxide is gone out of our body. Now let's look at the fourth and the final life process, excretion. So what is excretion? It's the process and system in which our blood is filtered because over time, due to chemical reactions, some waste material is accumulated in the blood. So the main components of this system is 2 bean-shaped kidneys, 2 excretory tubes or ureters, 1 urinary bladder, and the urinary opening of the ureter called the urethra. And the processes involved, there are 2 processes involved: filtration and absorption. Before that, I want to explain to you what is the basic structural and functional unit of the excretory system. It's called a nephron. It is a cell, and in each cell, this process of filtration and absorption occurs. So filtration occurs in the Bowman's capsule, which is a cup-shaped end of the nephron. You can see it in the figure. It's called the glomerular capsule. So the waste is filtered out over there, but the useful substances such as proteins and RBCs are left in the blood. And the second process, absorption, is when the renal tube as you can see in the figure, the renal tube reabsorbs the nutritions from the blood because it's essential. This includes water, sodium, and other useful nutrition. So after filtration and absorption, the solid waste material, mainly in the form of urea, will be passed through the ureter from the kidney to the bladder, where it will be stored temporarily and then thrown out at regular intervals. So this is my presentation. Anyone has any doubts? Anyone? Okay. if
What's
no-
the Bowman's capsule?
Yeah, so the Bowman's capsule is the cup-shaped end of the nephron. The nephron is the basic structural and functional unit of the kidney. I will just show to you here. Can you see this cup-shaped thing?
Yes.
Yeah, this whole thing is the nephron. I mean the Bowman's capsule. That's why the filtration occurs. Thank you for asking the question. Do you have any more doubts? No. Anyone else? Any doubts?
I guess it's very well explained, very well done. Okay. I mean, it's very deep, detailed, and the slides are also very good, very like catchy to eyes. I mean, the colors and all the things are very good, Abigail. So, can we have a clap for Abigail for her presentation? Yes. Now it's time for Ira. I guess Ira, no?
Yeah.
Okay. So, can we have a clap for Ira so that she can present her presentation to us? Over to Ira.
Like you can see my screen.
Yes, yes.
Okay, I'll start.
Yes, we can see that.
Okay. Hello everyone, and today I'll be presenting my project on the biosphere, which is Earth's life support system. I'll also be talking about Biosphere 2, a large experiment where scientists try to copy Earth's ecosystem inside a closed structure. So, what is the biosphere? The biosphere is the part of Earth where life exists. It includes all living things, from trees, animals, insects, and even tiny bacteria. But it also includes the environments they live in, like water, air, and land. The biosphere isn't just one place, it covers the entire Earth, from the deep oceans to the high mountain tops, and even underground in some places. It plays a crucial role in recycling nutrition, producing oxygen, and maintaining a stable climate, allowing life to continue. We can divide the biosphere into two major parts. These are Earth's life zones. The biotic components, these are living parts like plants, animals, fungi, and microorganisms, and abiotic components. These are non-living things that affect life, like sunlight, water, air, temperature, and soil. So the biosphere is a complex system where everything depends on everything else. To understand the biosphere better, we also look at the four major Earth systems, or four spheres. The atmosphere, these are all the air and gases around the Earth. The hydrosphere, like all the water, including oceans, lakes, rivers, and even underground water. The lithosphere, Earth's landforms like mountains, rocks, and soil. And finally, the biosphere, where all living things interact with the atmosphere, the hydrosphere, and the lithosphere, the air, water, and soil. These spheres work together. For example, a tree, which is biosphere, absorbs carbon dioxide, which is atmosphere, takes up water, which is hydrosphere, and grows in soil, which is lithosphere. I also wanted to talk about the Biosphere 2 because it's directly connected to the Biosphere 1. It was built in Arizona, USA in the early 1990s. It's called Biosphere 2 because Earth is Biosphere 1. It was a giant glass building about the size of 3 football fields. Inside, scientists created 7 different biomes or environments. a rainforest, a desert, a mini ocean with coral, a mangrove swamp, a savanna, an agricultural area for food, and living quarters for humans. The goal was to see if people could survive in a closed system without relying on outside air, water, or food, just like in space or on another planet. Well, what did they learn from this? 8 scientists lived inside the biosphere for 2 whole years. They grew their own food, recycled their own water, and controlled the climate. But it was not easy. Some of the problems they faced was oxygen levels dropping dangerously low, and they had to add in extra oxygen. Carbon dioxide levels increased way too much, which affected plant and human health. Insects that were important for pollination disappeared. Some plants died, and food became hard to grow. Biosphere 2 showed us how difficult it is to copy Earth's balance. Even small changes can have big effects. So, why should we care about all of this? Understanding the biosphere helps us fight climate change by learning how ecosystems work, protect endangered species and natural resources, create better farming and water supplies, and even prepare for space travel, where humans might have to live in enclosed environments like Mars colonies. I had built a small ecosystem just like 1 month back, and in this ecosystem showed me that how Earth recycles air, water, and nutrition. So just a few days back, I observed a small worm which was eating all the bad bacteria from my ecosystem and killing all the unnecessary mold. This mirrors what scientists discovered in Biosphere 2. I also thought about a place called Yellowstone National Park, where wolves were reintroduced after being gone for decades. This one change triggered trophic cascade, elk population, which was way too much, shrank. Vegetation rebounded and riverbanks stabilized. This example, along with my ecosystem, taught me that ecosystems are deeply interconnected. Changing one element can affect the whole system. To sum up everything, the biosphere is Earth's life zone, where all living things interact with their environment. It's the only known place in the universe where life exists. We have only one biosphere, so it's our job to protect it for future generations. Thank you so much for listening to my project. I hope you learned something new and interesting about the biosphere.
Very well done, Ira. I mean, it's really good that you did a practical also, and I mean, we all are amazed. Yes, are we amazed? Yes, I mean the practical things and showing all these things and making a video. It means that it's a great work and great, very well explanation. And even when you are teaching, the expression of showing your presentation, your breaks and saying the things, it's very good. And presentation was also very good. So congratulations to Ira. So everyone can we clap for Ira? Yes. So now it's time for our Joshua, the leader, will lead us into presentation. Over to Joshua.
Yes, sir. Can you see the screen?
Yeah, Joshua, you have to say a little louder, okay? Little
Can
louder.
you hear me? Sir, can you hear me clearly?
It's little low, but you can say a little louder if possible.
Hello everyone. Today I'll be talking about global warming. So, what is global warming? Global warming is the long-term heating of Earth's climate system observed since the pre-industrial period between 1850 and 1900s. So, global warming was found out a long time ago, and scientists discovered that due to the greenhouse effects, the earth started to heat more, and it caused so much like deforestation and forest fires, etc. So it which increases heat trapping greenhouse gases levels in Earth's atmosphere. This leads to rising global average temperatures and changes in weather patterns. What does global warming affect the How does global warming affect the environment? Global warming affects the environment in many different ways, including rising temperatures, sea level rise, drought, flooding, and more. These events affect things that we depend upon, like and value, like water, energy, transportation.
Joshua, I think slides are not changing. We are stuck on the first slide, which is global warming and the Earth is there. Can you click the second one and third one?
Yeah,
Which is
it
on your-
shows here. It shows the second slide. Can
Oh,
you see it now?
we are just seeing the first slide, I guess. Sorry to interrupt.
Wait, let me restart the
Yeah,
share.
restart it.
Can you see it now?
Yeah, now it's correct. Perfect.
So, how does global warming affect the environment? Global warming affects the environment in many different ways, including rising temperatures, sea level rise, drought, flooding, and more. These events affect things that we depend upon and value, like water, energy, transportation, wildlife, agriculture, ecosystems, and human health. So, global warming affects many things which we value, like uh, trees, deforestation, and many more. And it can also cause weathers like tsunamis, whirlwind, and stuff. How does greenhouse gases play a role in global warming? The greenhouse effect is a natural process where certain gases in the atmosphere trap heat, keeping the earth warm enough to support life. However, human activities have been increasing the concentration of these greenhouse gases, leading to enhanced warming and contributing to climate change. So, natural greenhouse effect is a natural process where certain gases in the atmosphere trap heat. They keep us suitable heat which doesn't make us too hot or too cold. But then there's a enhanced greenhouse effect. This is caused by humans because of factories cutting down trees and etc. So so it's leading to enhanced warming and contributing to climate change. What are the two types of greenhouse effects? There are two types of greenhouse effects. The first one is a natural effect. The second one is the enhanced effect. So, what is a natural greenhouse effect? The natural greenhouse effect is a process where certain gases in the Earth's atmosphere traps some of the sun's energy, warming the planet to a temperature suitable for life. Without these greenhouse gases, Earth would be too cold to support life as we know it. So, the natural greenhouse effect puts a suitable temperature which helps farmers, which helps also us in our daily lives. But the enhanced greenhouse effect is more dangerous. Like the enhanced greenhouse effect refers to the intensified warming of the Earth's atmosphere due to increased concentration of greenhouse gases. So it can be caused by petrol, oil, or manufacturing, or cutting down the trees, and it can also be caused by nuclear plants also. So while a natural greenhouse effect is essential for maintaining a habitable temperature on Earth, the enhanced effect leads to global warming and climate change. So the enhanced greenhouse effect is the one that's leading to global warming, deforestation, and forest fire. Okay, that's all. Thank you.
Very well done. Very well done, Joshua. It was very great. And I love it's global warming, which is related to heat. and you use red background for that, so it's showing that it's a danger sign for us. Yeah, so it is very good, very well prepared, very well think. Okay, Simeon, you can send that presentation to me so I can share it from here if it is problem for you, like it is any problem while sharing. Okay, you can try to send it to me in my personal WhatsApp, and then I'll share it from here. Okay, Simeon, no problem. Okay, so it's very well done, Joshua. Good presentation, good way of speaking. I liked it. Good. So now we'll go to, I guess, Jashron, if I'm not wrong. Yes. So we have J for Joshua. Now we have J for Jashron. So can we clap for Jashron for her presentation? Over to Jashron.
Thank you, sir. One moment. Yeah. Okay. Good morning, everyone. Today I've been asked to present on rotation and revolution. And rotation and revolution are two distinct types of motion, although they may sound very similar and people hear them in the same sentence, but quite often they are very distinct. Rotation is defined as a spinning of an object around its own axis. An example would be the spinning of the Earth around the axis, which it goes around the sun. An axis is an imaginary line that is mostly used to show the planets that go around the sun. The Earth's rotation causes for us day and night. Some more examples of rotation are a spinning top, a merry-go-round, could say a Ferris wheel as well, but I'm not going to go that much into amusement parks. Revolution is defined as the movement of one object around another. The Earth's revolution around the sun causes the change of the seasons. So when the Earth reaches one part in its revolution around the sun, it will be spring for us, and another part it will be summer in the southern hemisphere and winter in the northern hemisphere, and another part will be winter in the southern hemisphere and summer in the northern hemisphere. To summarize, the Earth's rotation on its axis gives us the familiar cycle of day and night. The Earth's revolution around the sun, combined with the perfect tilt of its axis, is responsible for the change of seasons. The moon's revolution around the Earth is responsible for the tides. Whenever I look at, hold up, one moment. Whenever I look at the beauty of God's creation, especially seeing the beauty of the earth and everything that God has made, I always think of his glory. And this verse is a very good way of saying it. The day is yours and also the night. You established the moon and the sun. God's glory shines above everything else. And I don't know if my presentation is taking 5 minutes. I'm sorry, but thank you for your time and the opportunity to present today.
Very well done. Very well done. Can we have a clap for Jashron? Yes, very well done, Jashron. It was good. It can be lengthy, but it's okay. No problem in that. And especially, I like that part in which you said that it's all God's glory. God establishes the sun and moon. So it's very well done. That means that you did a good Bible reading in this 1 month. Yes. Okay, very good. Very good. Now we have Simeon. Simeon, are you ready?
Sir, can I go last? I'm still just opening it in a different device.
Okay. So we'll have now Betya in between us from Rajasthan. So can we have clap for Betya? Now over to Betya.
One second.
Okay. So till Betya is adjusting her presentation, I want to say your guys' presentation was very good. It was beyond my imagination. See, I'm not a computer techie guy. Okay. So I used to teach it like before when I started my NXT classes. I remember that I put tripod, I turn on my camera, and there's a physical board. I used to teach on that. Okay, then I evolve it. Now I think from the next sessions or next to next sessions, I have to start my presentation also. So, and I can come to you as a student that, sir, please teach me about your presentation, how you make, how you do, like that. So, yeah, it's very good. One request is there, to access that everyone can access your presentation, you can send it into the group. Okay. So in our 10th class group, you can send it to us. Okay. It's gonna be our memory also. And for example, if Ira wants to know about Edric presentation more, so she can see it in the group. So it's gonna be good if you will send it to me in the 10th class WhatsApp group. And please send me your address after this class so that you guys, whoever's a winner, can get the prize from NXT class. Okay, over to Betty.
Can you guys see my screen?
Yeah.
So I'm going to be talking about waste management today. Waste management towards a cleaner and greener future. What is waste management? Waste management is a process of handling waste from its source to final disposal. Our aim is to protect health and environment, conserve resources, promote sustainability. Types of waste. There are three types of waste we have. There's organic, there's recyclable, and there's hazardous. So in organic, we have two types. We have wet and dry. So we can separate those in two different ways. And then recyclable, we have papers, cardboards, metals, steels, and all those things, which we can recycle. And then hazardous is like all the electronic items like TVs, old phones, batteries, and stuff, etc. Waste management methods. Segregation at source, so we can segregate all these wastes from our house, so it will be easier for the people who take these trash away. Then recycling, plastic, metals, and papers, we can give all these to the scrap dealer, and then the scrap dealer can give it forward so that these can be recycled. Then we have composting organic waste, and then it is collecting and transport, treatment and processing, and the end, we should always keep landfill the last resort. 3 R's. Reduce, recycle, reduce, reuse, recycle. How can we reduce? Minimize waste generation. Example, avoid single-use items like plastic bags, plastic bottles. Reuse. Use items multiple times like bags, bottles, containers. Instead of using plastic bags, we should use cloth bags for grocery shopping and stuff. Instead of plastic bottles, we should use metal or steel bottles to drink water. And then containers, instead of plastic containers, use glass containers. And then we have recycle, convert waste into reusable material. Reasons why we are not able to deal with it effectively. Inadequate segregation. When waste is not properly separated into categories like wet, dry, recyclable, and hazardous at the source, making recycling and treatment harder and impossible. So when we don't segregate it from its source from the start, then because of that, we have overflowing landfills that have reached or exceeded their full capacity, leading to waste spilling over and causing pollution, bad odors, and health hazards. So when we don't segregate our wastes properly, we get overflowing landfills, and then the electronics like old phones, batteries, computers, and hazardous substance like chemical or medical waste that are dangerous to human health and the environment if not handled properly. Low public awareness. When people don't know enough about waste segregation, recycling, or harmful effects, or improper waste disposal, resulting in poor waste management practice. Overconsumerism is a really huge problem. What can we do to prevent all these to happen? Deal with overconsumption, use biodegradable products for single use, separate waste at home, try to use the wet waste in garden, recycle or give it to scrap dealer, avoid plastic and disposable items, participate in cleanup drives, educate others about waste management. Conclusion: waste management is a key to a cleaner planet. Everyone's efforts count. Small actions make big impact. Don't be trashy, manage your waste responsibly. Thank you.
Very well done. Very well done. Okay, good confidence. Good confidence. Good way of speaking. Like when you're speaking, it's not look like you are nervous. So it's good. Very good. Good green color presentation, which looks like you are doing a good waste product. You want green Haribari planet, like green planet. So it's very good. Very good. So now we have Simeon in our midst. Can we have clap for Simeon so that he can represent his presentation? Over to Simeon.
Can you see my screen?
Yeah, right now it's white.
Yeah.
Okay.
1 second. Yes. Good morning, everyone. Today I'm talking about pollution and its causes. What is pollution? Pollution is defined as the addition of undesirable substances into the environment, resulting in harmful changes. Just 1 second. It's having a problem. One second, sorry. Pollution can be broadly classified into air pollution, water pollution, and land pollution, but also includes noise, light, and plastic pollution. Additionally, thermal, radioactive, and visual pollution are recognized forms of pollution. Now let's look at what is air pollution. Air pollution is the introduction of a substance which has harmful or poisonous effects into the air. A recent air pollution incident in Tamil Nadu occurred during Deepavali celebrations in Chennai on October 31st in 2024, where air quality monitoring stations reported consistent poor air quality due to the bursting of fireworks. What is water pollution? Water pollution is the introduction of a substance which has harmful or poisonous effects into water bodies or sources. A recent water pollution incident in Kerala occurred when the ship Elsa 3, en route from Vizhinjam to Kochi, tilted into the sea around May 24th, around 38 nautical miles off the Kochi coast, and sank completely the next morning. According to India's Ministry of Defense, the ship had 640 containers, of which 46 were washed ashore in South Kerala on Tuesday, May 27th. The ship released many chemicals, oils, etc., which it was carrying, and caused many fishermen to lose their livelihood, since they were not allowed to sell their catch as it could be contaminated and poisoned. This is the third and last type of pollution I'm speaking about today. Land pollution. Land pollution is defined as the deterioration of the Earth's land surfaces at and below ground level caused by human activities. A significant land pollution incident occurred in March 2019 in Malaysia, involving the illegal dumping of chemical waste on the banks of the Kim Kim River. This caused the release of toxic fumes, affecting approximately 4,000 people, primarily children, who experienced breathing difficulties and other health issues. The incident highlighted the vulnerability of local communities and the consequences of unregulated chemical waste disposal. Now, I just wanted to show where the Kim Kim River is in Malaysia for those who don't know. So this blue line on the map is the Kim River. Now let's look at the effects of pollution. These effects can be direct and immediate or long-term and chronic. Human health impacts, respiratory issues, air pollution, including particulate matter, which is PM 2.5 and PM 10, which is particulate matter of a diameter of 2.5 millimeters and 10 millimeters. Ozone and nitrogen dioxide can cause or worsen respiratory problems like asthma, bronchitis, and chronic obstructive pulmonary disease. There are other problems for human health like cardiovascular problems, cancer, neurological damage, reproductive issues, and increased mortality, which all comes under effects of pollution. Environmental impacts, ecosystem damage, water and soil contamination, climate change, acid rain, and wildlife harm are all environmental impacts because of pollution. Socioeconomic impacts, economic costs, reduced quality of life, and other impacts can impact our life and livelihood. Specific examples of pollution that cause this are particulate matter, ozone, heavy metals, pesticides and herbicides, plastics. How do we prevent pollution? To prevent pollution, we can use the AFR method. Analyze the problem, identify the type, location, affected parties, extent sources, and mitigation efforts by asking questions like, is it air, water, or land pollution? Where is it happening? Who or what is affected? What are the potential consequences of the pollution? We should collect information about the extent of the pollution, its sources, the contributing factors, and the current mitigation efforts. The next step is to find the root cause of the problem. Based on your analysis, identify specific activities, industries, or behaviors that are causing this pollution. This might involve looking at factors like industrial emissions, vehicle exhaust, agricultural runoff, improper waste disposal, or faulty infrastructure. We should learn how the pollutants are being released into the environment and what environmental conditions might be exacerbating the issue. For example, certain types of weather like rain can trap pollutants in the atmosphere, while specific geological features might influence water flow and pollution dispersion. The third thing we can do is remove the cause. We can address the root cause by modifying our practices, adopting cleaner technologies, enforcing regulations, and promoting sustainable alternatives. Involve stakeholders, raise awareness about the issue, and encourage participation in pollution reduction efforts. This can include community outreach, public campaigns, and policy advocacy. Establish a system to track progress, ensure compliance with regulations, and address violations. This might involve inspections, fines, and legal action against polluters. Now, I just want to share some fun facts. Approximately 9 million deaths in 2015 were linked to pollution. Every year, the global population generates approximately 1.3 billion tons of waste, equivalent to the weight of 6.5 million blue whales. Exposure to air pollution during early pregnancy increases the risk of birth defects. 4. Plastic pollution led to the creation of this Great Pacific Garbage Patch, an island of plastic triple the size of France. 5. New Delhi's air quality level can reach up to 40 times the World Health Organization's safety limit. Thank you. I learned a lot while doing this presentation.
Very well done, Simeon. I mean, can we have a good clap for Simeon? Yes, I love that you use the current facts in your presentation to explain about what we have, especially Kochi and especially the air pollution one. So it's very good. It's like a research paper, like those who do PhD in. So you can do in coming days PhD in pollution. So and you can find the AFR method and use the root cause, and then you can be the next Elon Musk. So you can do all these experiments and inventions. So it's very good, very well done. So everyone did very good part of their presentation. So now Sam, are you there, Sam? Sam, can you hear me? I guess Sam is not there. Samuel is there? Yeah. I can't hear you. You're saying something. Yeah. Yeah. So you learned something? I mean, you learned too many topics today?
Yeah, kind of.
Kind of. So who you like most?
Which one I like most? It's
Yeah.
hard to decide that.
Same here. Same here.
Because everyone did nicely actually.
Yeah. So I guess everyone is the winner. So, but it's a surprise for them if they will receive the prize. If they receive the any gift from Amazon, then it means that they are the winner. But if they didn't receive, then they are the good participants. Okay. So from this end, we'll end this class. We'll end this presentation ceremony. Once again, we will clap for everyone for their participation, for their doing great work in this break. They didn't waste their holidays, but they did a great work. So with this end, we'll end this class. I hope you enjoyed the presentation ceremony. Till then, bye. Have a nice day. Signing off. Sayonara.